The question says that figure 12.8 shows plot of PV by T versus P for 1 multiplied by 10 to the power minus 3 gram of oxygen gas, that is 1 gram of oxygen gas for two different temperatures T1 and T2. Now what does the dotted plot signifies? So here PV by T versus P graph is given. So we see that PV by T is constant in this dotted line. So as per the ideal gas equation, it is PV equals to nRT or PV by T equals to nR, which is constant. So we can say that if this is a straight line parallel to the x-axis, so it is going to depict the ideal gas. Now in the second part we have which is true, T1 is greater than T2 or T1 is less than T2. That is, this temperature is greater than T2 or less than T2. So we know that as temperature increases, real gas behaves more like ideal gas. So curve near the ideal gas line has a higher temperature, or the curve near the ideal gas, that is T1, has higher temperature than T2. So here it would be T1 is greater than T2. Now the third question is, what is the value of PV by T where the curve meets on the y-axis? So when the curve meets at the y-axis, that is at this point, what is the value of PV by T? So this height is, we have to find out this height. We know that PV by T equals to constant, that is nR. N is the number of mole and R is the gas constant, universal gas constant. For number of mole, we haven't given the data, that is the gas we are considering here is 1 gram of oxygen. So for finding out how much mole is there, we will divide this 1 gram by its molar mass that we can see over here. We will get the value of nR as 0.256 joule per Kelvin. This is number of mole and this is the gas constant. So in the fourth question we have, if we obtain similar plots for 1 gram of hydrogen, would we get the same value of PV by T at the point where the curve meets the y-axis? So if this gas was oxygen, will the value of PV by T that we calculated for oxygen will be the same? The question is asking. So as we see in the calculation over here, that this nR depends upon the molar mass of the gas that we are talking about, and in the case of oxygen we have 32 and in the case of hydrogen it is just 2. So its value can't be equal for the oxygen gas or hydrogen gas, so it will change. Now if not, what mass of hydrogen yield the same value of PV by T? So we already know that it is not equal. So we have to find out at what mass the hydrogen yields the same value as that of oxygen. So we know the PV by T value for oxygen, that is 0.256, and if we want to know the mass at which the hydrogen will yield the same result, so let M be the unknown value, and here capital M or the molar mass of hydrogen is 2, and we know the gas constant, so we can equate this with the known value of 0.256 for oxygen. So calculating this value for the mass of hydrogen, we get 6 into 10 to the power minus 5 kg. So this much gram of hydrogen is required for it to have the same value of PV by T. Thank you.